So, in this session, we will talk about feature scaling and why it is necessary. So, feature scaling it's also an important AI pre-processing steps, and we'll be discussing about what is normalization and standardization in this session. So, why feature scaling is important and why do we do that? So, different features, right? They often live on very different numerical ranges. What I mean by different numerical ranges is, for example, if you want to analyze the performance of employees in a company, and if you load that data with specific numbers like salary, their like someone is earning like 50,000, 60,000, someone's like 100,000, and other features like their age 25, 35, the system is going to look at some one particular numbers which are higher numbers, so maybe his salary, and bias towards it. The algorithm gets biased towards those larger values, like one with the highest salary is a high performer, and that's not really the signal we are actually looking for. And so scaling puts these features on comparable footing. So the model's attention is driven by signal, not by the actual number, like the large number. And for example, in standardization and normalization, right? So there are many algorithms, like especially the one with the KNN, which is K nearest neighbor, SVM, and different algorithms. I mean, like if we scale those features, we can analyze the data. The system can analyze the data. So what is normalization? As you can see, normalization is the formula is x minus x minimum by x max minus x minimum. So what it does is called it's a min and max scaling. And what it does is it squeezes every value in the range of 0 to 1. And so once it squeezes this value in 0 to 1, what exactly happens here is it keeps the relative spacing between the values, but it also guarantees that they are bounded with each other. So when I was talking about the like the range of salary range, yeah, if there's like 60,000, 80,000, 120,000, just by seeing the numbers you can see 120,000 and 80,000 are more connected to each other than the one with the 60 to 80,000, and that's biasing. But if you normalize those values, you get a specific number, and you can actually understand that, okay, the one by the normalized values, you can see they are more connected to each other. And now this feature scaling, this normalization and the standardization, they're always done in the columns, not in the rows. I will show that later. Okay. And one there's a caveat to it. So if you get a new data point outside this original max or minimum, it can slightly fall below this 0 and 1 sometimes. So always fit the scalar on the training set whenever you're training the model, and apply the same transformation to whenever you're validating or training or testing the data set. So let's look at this with an example. X minus x minimum. So let's normalize the one with the value 30 as shown here. So the minimum is 10 and maximum is 40. So as we saw, we are normalizing 30. The 30, we are going to take 30 over here, and minimum value is 10, and 40 minus 10. So you get 0.67. And that is an example of a normalization. Just hold on to it and let's see what is the standardization. Once we understand the standardization, I will show you what is the importance of normalization standardization in the future slides. So here in this standardization, you can see x is the value which you want to standardize. U is the mean of the value, that is the sum of the value divided by whatever the, if you have four values, sum of those values divided by 4, and the standard deviation. So yeah, this standardization is also called zero score scaling, and each feature, it rescales data to have a mean value of 0 and rescale so that standard deviation is 1. And this is the formula. As we can see, they're used in like many models like linear regression model, logistic regression, PCA, k-means clustering, And even many algorithms, that assumes like roughly the Gaussian shaped inputs and things like that. So one key difference between normalization and standardization is here the normalization, it's very susceptible to outliers. So what I mean by that here, if a single outlier pushes any value, right, like this 40 to a 400, then most values shrink towards zero. Now that's the main reason normalization is very sensitive to outliers. But standardization, it's not like that. It is typically less sensitive to extreme min or max than min max scaling. So there are really true robust methods exist if they have outliers. Even to there's a solution for that one. Now let's look at the standardization example over here. You see there's these are the features. The features are height features 150, 60, and you find the mean. The mean is this is the mean, and this is the standard deviation. How you find the mean? You sum up this and divide it by 4. And standard deviation, I will show you how you, and you are finding the standardization for the value 180. You can find for 150 also. For 180 minus 165 divided by ln 0.18. And as I mentioned previously, they are less affected by outliers compared to normalization. So let's find how the standard deviation came. The standard deviation is very simple. Sum of the all the values divided by 4, you get 165. And once you get that, you can actually see the standard, you know, mean average. And the standard deviation is nothing but this value, the lower formula, the row which you're seeing. This, how you actually find out is, look at this formula. This is root of 1 by n, the sum of all the values and the value which you're trying to do standardization minus the mean. So 150 minus 165 equals minus 15. So 15 root of square is 225. Same way you do for 160 and 180. And once you do that, you sum. You see this is a summation where you sum, add all of them by 500 and divide that by the 4. You get the 11.18, which is the standard deviation over here. So that's pretty much the standardization, normalization. And so you can see this is the final value for 180. If you standardize, same way you can pause this video, do the same thing we did for 180, value 180. You can try for 150 or 170, same, 170 minus 165 by 11.8. And if you are doing the for 170 over here in this values, you find the standard deviation, and you try to do the same thing over here. So that's pretty much about it. So mean is 165 and standard deviation 11.8. So now